Welcome to The Explainer. Today we're looking at something that, honestly, just shouldn't exist. It's a piece of software, a real ghost in the machine. And it's a story about pushing ancient tech way, way past what anyone thought was its breaking point.
All right, just take a good look at your screen. It's an interface we all know, right? You've got a graphical desktop, windows you can move around, a taskbar down at the bottom. There's even a clock and a start menu. It looks like a lightweight version of what you'd find on any modern computer.
But here's the twist. It's not running on a modern computer. Not even close. This whole thing, this graphical multitasking operating system, is running on an 8-bit home computer from the 1980s. We're talking something like an Amstrad CPC, powered by a little Zilog Z80 processor.
So, that creates this fascinating paradox, doesn't it? How in the world do you run a sophisticated, modern-style OS on hardware that's literally orders of magnitude less powerful than the smartwatch on your wrist? That's the big question we're going to unravel today.
Okay, so let's dive right in. To really get how SymbOS works, we first have to understand the incredible motivation that even sparked its creation in the first place.
The project's own documentation puts it perfectly. They called it an experiment to implement a multitasking OS with a windowed GUI on an 8-bit computer from 1985. So you see, at its heart, this was never about making money. It was a challenge, driven by pure curiosity. Could you really make a mini Windows run on a 20-year-old machine?
And the goal. Oh, it was incredibly ambitious. This wasn't just about creating some cool little demo. No, the dream was to make these classic machines genuinely usable in a way that feels totally familiar to us today. And that passion, that drive, has made SymbOS one of the biggest and most impressive retro computing projects out there, period.
Okay, so that brings us back to that big question. How on earth did the developers actually pull this off? It seems impossible, right? Well, the magic is all in a few extremely clever design choices. The whole thing starts with the OS's core design. See, a lot of operating systems use what's called a monolithic kernel, basically a giant all-in-one core that handles everything. But SymbOS, it uses a microkernel. That means only the absolute most essential functions are in the core. This keeps it incredibly small, super fast, and really efficient, which is just perfect for a resource-starved 8-bit computer.
Now, to handle running multiple programs at once, SymbOS uses this really clever hybrid approach. For all the critical background stuff, it uses preemptive multitasking. That means the OS is the boss, and it decides when to switch tasks. But for the apps you're actually using, it uses cooperative multitasking, where each program kind of politely hands over control when it's done. This combination is absolutely key to keeping the whole system feeling responsive.
But the single biggest hurdle, the real mountain they had to climb, was memory. The Z80 processor, the brain of these machines, could only see 64 kilobytes of RAM at any one time. To put that in perspective, that's barely enough for a single small image on a modern web page. Think of it like having a tiny little desk that can only hold a few pieces of paper at once.
And yet, SymbOS is designed to manage up to 1,024 kilobytes of memory. That's a full megabyte, 16 times more than the CPU can technically handle on its own. So how? How does it do that? Well, the solution is this brilliant workaround called bank switching. Okay, remember that tiny 64 KB desk we talked about? Now imagine that the full megabyte of RAM is a huge filing cabinet right next to it. Bank switching is like having a lightning-fast assistant that is constantly, and I mean constantly, swapping folders from that cabinet onto your tiny desk for the CPU to work on. It happens so incredibly fast that from the CPU's point of view, it feels like it has access to the entire filing cabinet, even though its desk is still tiny. It's just genius.
So, with all this technical wizardry humming away under the hood, what's it actually like to use SymbOS? Well, the result is an experience that feels, frankly, surprisingly modern and complete.
The graphical interface itself is designed to be super intuitive, right? It's got that familiar taskbar, a start menu, and you can have up to 32 movable windows. And to make sure it's not painfully slow, the entire system is written in highly optimized assembly language. We're talking a programming language that speaks directly to the hardware, squeezing every last drop of performance out of that old Z80 chip.
But SymbOS doesn't just look like a modern OS. It acts like one too. I mean, it comes with a whole suite of applications that mimic the software we use every single day. There's a web browser called SymZilla, a music player called SymAmp, and of course, a file manager called SymCommander.
And for those of you who want a bit more power, underneath that pretty graphical interface is SymShell, a full-featured command line.
It supports all the essential commands you'd expect, like dir to list files, and copy to duplicate them. This really proves that SymbOS isn't just some graphical shell. It's a complete, functional operating system through and through.
Now, this incredible project didn't just appear out of nowhere overnight. Not at all. It has been a long, constantly evolving journey of development, and that journey continues to this day.
It all started way back in 2006 with the first release for the Amstrad CPC. From there, SymbOS has just steadily expanded its reach. Over the years, it's been ported to more and more machines. The Amstrad PCW, the Enterprise 128, and most recently, the ZX Spectrum Next, just growing its family of supported retro computers all the time.
And the real genius of SymbOS is its modular design. By keeping the core OS strictly separate from the hardware-specific bits, an application written for one machine can run on any supported computer without a single change. This write once, run anywhere idea, that's a monumental achievement on 8-bit hardware. So in the end, SymbOS is way more than just a piece of software. It's a real testament to human creativity, and it forces us to ask a pretty compelling question. Are the limits of technology really defined by the hardware itself, or are they just a reflection of the limits of our own imagination?